Welcome to the Bentley Systems training course where you will learn how to generate wind loads for open building structures in RAM elements according to the ASCE 7 main wind force resisting system. In this particular video, we will review our finished model in RAM elements, assuming all that the wind load definitions and wind load cases are complete. For the open structure that we used in this series of videos, we generated wind loads in both the X and Z directions. Since the open structure that we are loading contains a pitched roof, we did create additional load cases so that we could consider both case A and case B. As a reminder, it is helpful to have a good familiarity with the code requirements to ensure that all load cases and scenarios are accomplished through your finished model. We will now turn our attention to the completed model in RAM elements to review the rest of the information that has been provided. First, let's go ahead and take a look at our load cases. And as you can see, 4 load cases have been generated in each direction. For this particular model, we decided to consider both the positive and negative X directions, and since we have a pitched roof in our open roof structure, we also chose to consider both case A and case B. Now, in addition to that, let's also go ahead and take a look at the load definitions that were required for all of these scenarios. Let's start by going to the Home tab of the ribbon toolbar, and then let's click on the wind definition icon. Now, here, let's go ahead and take a look at the X direction. As you can see, I have 2 different wind definitions for the member loads in the X direction. I considered both the positive direction and the negative direction. Now, the one major parameter that changes between the positive and the negative direction when we're talking about member loads is this wind direction field. As you can see here, 0 degrees would indicate wind load in the positive X direction, and then switching that over 180 degrees would be the negative X direction. I did that same process for the Z direction as well. Positive Z would be 90 degrees and negative Z would be 270 degrees. In addition to that, I also generated 3 load cases for each case in the X direction, considering the distances from the windward edge of 0 to H, H to 2H, and then also anything greater than 2H. Now, as a reminder, we do recommend that you have your code in front of you as you're generating your wind definitions to ensure that all cases and scenarios are covered in your finished model. Now, as you can see, if we move forward to the Z direction, I also generated a windward and leeward definition for each case in the Z direction. Let's go ahead and close on out of this dialog. Now, if you wanted to double check after you make your assignments that the appropriate wind definition was assigned, you can do that through the data panel. If we're talking about members, you're first going to select your load case. Let's go ahead and select one of the negative load cases. We can go to the Members tab and then go to the Wind Load Definition icon. This icon is available when the Loads on Members icon is active. Here I can see all the load definitions that were assigned to the currently selected members. Now, if we're talking about areas, I can repeat that process, going to the Areas tab, and then also selecting this Wind Load Definition icon. This is a great place to go just to double check your work and make sure the appropriate wind definition was assigned for whichever case you're taking a look at. Now, as a reminder, only one wind load definition can be assigned to either a load area or a member for each load case. In addition to that, it's also important to remember that if anything within your wind definition changes after it's assigned, you do need to go ahead and reassign it to make sure those changes are incorporated in your final loads. So say, for example, within this load case, if my basic wind speed changes, I should just come back and repeat that process for reassigning the load. And as always, again, only one wind load definition can be assigned to each area, so it'll just override whatever was previously assigned. Now, if for whatever reason you need to delete your wind pressure, we also have a tool available for that in the Spreadsheet tab of the ribbon toolbar. This is available for both areas and members. Now, after you go ahead and assign all your wind loads and are fairly satisfied with your work, you are also able to review your information that you assigned and the calculations through a report. Okay, so for this particular model, we'll go ahead and keep everything selected. We're going to go to the Output tab of the ribbon toolbar, and we can click on the Analysis, and we can click on the Data icon. Here, if we select this Loads option, we are able to review the wind loads. Now, this will be similar to the report we were able to see when wind definitions are assigned to either members or areas. But say, for example, you want to see that information a little later in your workflow. You are able to review that information through this report. So here I'm going to go ahead and tell the program I want to review my wind loads, and I'm going to review my third wind load case in my X direction. This will represent wind load in the negative X direction for case A. Let's go ahead and click OK. Now, the way any report works within RAM Elements is that whatever's currently selected when that report is activated will be available in that report. So for this particular model, I have all the members and all the areas selected, so all of their calculations should be available in this report. Had I only selected the areas, I would only see the area information within this report. So let's go ahead and scroll on down. I can see each wind load definition that was assigned in this particular load case. I can see all of their repeat parameters in case I wanted to double check anything, make sure everything looked still appropriate. And then if we scroll on down, I have a section on area loads, including their final design pressure and all the variables that were used to arrive at that pressure. And I'm also able to see some similar information for the member wind loads, including the final load magnitude of that distributed load. Let's go ahead and close out of this report, and we're going to save our model. Now, at this point, this concludes our process for assigning wind loads to an open structure within RAM Elements according to the ASCE 7 main wind force resisting system. At this point, depending upon our workflow, we may be ready to move on to analysis or design.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.